Welcome back. All right, so we are going to do questions 11 through 20. Hopefully, you watched the first video, and if you didn't, these are only questions 11 through 20. Oliver will bark. I don't know. Just go with the flow. I'm doing this from home. I didn't even bring home my tablet pen. We're just going to do the things. All right. For polynomial function f, whereas x approaches negative infinity, our y values or our output, it approaches positive infinity. And then as x approaches positive infinity or increases without bound, my outputs decrease without bound. Here's what I know. I know that as it's going to the left, it's going up. And as it's going to the right, it's going down. You could have some squiggles in the middle, but it doesn't really matter because all I'm worried about are the end behaviors. So even functions have the same end behavior. I know it's not A, I know it's not B. The degree of f is odd and the leading coefficient is negative. Maybe. Degree of f is odd and the leading coefficient is positive. If it were positive, it'd have a positive slope. As you can see, this entire time it's decreasing, so it has to be C. I always do the cute little pictures off to the side so that I have a visual to go off of as well. All right. For the polynomial function g, as x decreases without bound, or as x approaches negative infinity, my output values also approach negative infinity. Which of the following expressions could define g of x? So I have no idea what's going on to the right, but I know that to the left, my end behavior is pointing down. I don't know what's going on to the right, but I know what's going on to the left. So now I'm going to look at each of these functions and determine if they satisfy that equation. Always focus on the leading term. My leading term here is a negative even function. So I know that negative evens both point down. It could be that, but hey, we're going to look at every single one. My leading term here is a negative odd power. So I know it'll be something like that. That's not what I want. This one's a little bit confusing. So remember, if I have negative x to the 5th over 5, I can just write that as negative 1/5 x to the 5th. And that's going to have the same end behavior as b. So that's not what we want. And then the leading term in d is 2x to the 4th, where both end behaviors point up. So I did all that work just to come right back to A and say that A is the winner. He's going to bark. All right. Wait, the function is blah, 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 blah. Which of the following correctly describes the end behavior as the input values increase without bound? So I know I want a limit notation that has x approaching positive infinity because that would be increasing without bound. Okay. So I'm going to eliminate C and I'm going to eliminate D because that's not the correct limit notation. Now I'm going to take a look at this. That has a negative leading coefficient and it's an odd degree function. So I know that it's probably going to look like that. Well, as x is increasing without bound, my output values are decreasing without bound. So it has to be B. I love end behavior stuff. I love limit notation because I'm a dork. All right, let's take a look at 14. The rational function, we love our rational functions, is this junk, and it's equivalent to P of x over Q of x, where their polynomial function was, which is true. Okay, let's just take a look at this. So they're basically calling the numerator P of x, and they're calling the denominator Q of x. That's it. That's what all that terminology means. So which is true? Is the degree of p of x, the top numerator, less than the degree of the denominator? Well, I have 1, 2, 3 x's up top. 1, 2, 3. And I have 1, 2, 3 x's in the denominator. So the degree of the top is 3. The degree of the denominator is 3. So that's not true. The degree of p is greater than the degree of q? No, we just said they're the same. So now, even if you don't know what you're doing, right, you can at least figure out that the degree of the numerator and denominator are the same. And now you got a 50-50 chance. It's asking specifically about end behavior. The only way I can get a 0 as an end behavior is if my denominator has a larger degree. And we just said that that's not true. It's D. Because if I were to multiply all these leading terms in my numerator, I'm going to get 2x to the third. And if I were to multiply all the leading terms in my denominator, I'm going to get 6x to the third. Well, that just simplifies down to 1/3. And that's where that 1/3 is coming from. I don't know if you can hear it, but Oliver is chewing his bone in the most obnoxious way. Hope you enjoy. All right. The function h is given by h of x. Which of the following is true? Oh my goodness. There are a bunch of different ways to approach this, okay? This is rough. Whew. We haven't really done this, but we need to find a common denominator. We need to combine like terms, and yuck. If I had like 1/4 and I had 1/3 and I wanted to subtract them, I need a common denominator. So I multiply the first term by 3 and the second term by 4 and do the things. Well, this is the part you're not going to like, because I'm going to have to multiply this by x minus 1 and this by x plus 3. So that's going to give me 2x cubed times x minus 1. And I'm going to subtract 4 times x plus 3. And I'm going to put that all over x minus 1, x plus 3. Well, here I can do some elimination. If I were to FOIL the bottom, that's going to give me x squared plus 2x minus 3. So I can cancel out C and D. Now I just need to figure out if it's A or B. I continue my foiling. I'm going to get 2x to the 4th. Stop right there. This one doesn't have a 2x to the 4th. It's A. It's a lot of math, but at a certain point, you will be able to stop and eliminate and move forward, and yuck. But we did it. All right. Rational function is given by this. Which of the following describes the end behavior? Remember, leading term divided by leading term. So that's going to be 2x to the 5th over 3x squared. So because my numerator has that larger degree, it's going to have the same end behavior as the quotient. And the quotient is going to be 2/3. That's not a 3, but that kind of is x to the third. It is a positive coefficient because it's 2/3. And it is an odd function. So I know that left to right, it's going to look something like that. Well, now let's pick one of these that has a description that matches that. As x increases without bound, h of x increases without bound. That's true. As x decreases without bound, h of x decreases without bound. Maybe. Yeah. I like that one. Well, let's just continue. As x increases without bound, h of x increases. As x decreases, h of x increases? No. And remember, h of x is just the y. Is it going up or going down? That's what that means. As x increases without bound, h of x decreases. Nope, that doesn't happen. As x increases, y increases. And since that says the same thing, we were right about picking A. Rational function is given by this. For what values does r of x equal 0? Guys, it's just a calculator thing at this point. I'm not going to do all the math and figure out and all that, because that's a cubic function up top. I don't know how to factor a cubic function, but I do know that I have a device that will help me do that. So all I would type in is x to the third minus 4x. I keep hitting the wrong button. Whoops. Plus 3. And I close my parentheses. That's so important. You have to be very, very diligent about that placement. And then in the denominator, I have x to the fourth. And then I have plus 2x. And then minus 4. Before I even graph this, my denominator has the larger degree, so I know that my end behaviors are approaching 0. Just keep that in mind. Let's do zoom standard and see what happens. Oh my goodness, what is this garbage? Miss, I have no idea what I'm looking at. It really is okay. We're trying to find where the zeros are. And if we were to just focus our eyes on, say, -5 to 5, okay? I can see that there's a 0 here, here, and probably somewhere around here. I could zoom in and look, but I have 3 very visible zeros. So let's go back to our thing. I don't know how to get that up. There it is. Okay. There's only one with 3 zeros, and it's C. Use the calculator. That is your friend. Use it. Also, if you didn't get to see the calculator, I am sorry. Just in case you didn't see it, because I forgot that I didn't share it the right way. There are 3 zeros. 1 in this area, 1 in this area, and then since it's going negative to positive, 1 in that area. 3 zeros. That's roughly -2. That makes sense. That's roughly 1. It's roughly 1.3. That all makes sense. So I can move on. Oh, goodness. Okay, we're back. We're back to where we need to be. All right, number 18. For what input values of G are the output values of G equal to 0? What does that mean? For what input values of G, so what x's make my output values y equal 0? Oh, I'm just looking for zeros. I just wrote it in a very confusing way. So let's take a look at my numerator. It looks factored. We can even factor it even more. So that x squared plus 3x, I can remove an x, and that leaves me with x plus 3. And then I need two numbers that multiply to -5 and add to -4. That's going to be x minus 5 and x plus 1. Great. Now let's tackle the denominator. Oh, the denominator's already done. I have the x plus 3, x minus 1, and an x minus 2. My zeros are all about the numerator. My vertical asymptotes are all about the denominator. My zeros are the things that cancel. I have an x plus 3 and an x plus 3. I have a 0 at x equals -3. And now I have 3 terms on the top. 0 would make that 0. +5 would make that 0. And -1 would make that 0. So it has to be B. All right, we just have 2 more questions for this mini, not so mini video. On what intervals is r of x greater than 0? Why don't we just graph this? And that's exactly what we're going to do. We're going to graph it. So we're going to go to our handy dandy smart view, and we're going to plug in the function that we care about. It is x cubed plus 4x squared plus 4x. And then my denominator is x squared minus 9. And that is my lazy way of fixing it. I'm going to go to Zoom Standard, take a look. Looks like something's missing, because there is. Just zoom out, just once. And now we can see all the things that we care about. We want to know where where y is larger than 0. Where is it above the x-axis? Well, there's 2 sections where it's above the x-axis. So let's take a look at our options. I'm looking for 2 intervals. That's only 1 interval. That's only 1 interval. This is 3 intervals. And then this is the one that makes sense. Because from -3 to 0, it was above the x-axis. And then from 3 forward, where it did that swoop into infinity, we know that that is what we're looking for as well. All right, 1 more for this video. 20. In the xy plane, the graph has a vertical asymptote at x equals 4, which could define f of x. Well, I need my denominator to have 4 as a value that makes it equal 0. So let's take a look at A. I have 4 minus x cubed and x minus 4. So if I plugged in 4 here and plugged in 4 here, I'm going to get 0 over 0. That lets me know there's a hole. But do you see the multiplicity of A? The multiplicity of A is 2, but the denominator has it as a 3. So because the denominator is winning, this is a possibility. If I look over here, that's to the second, that's to the second. they cancel each other out. It's just a whole. This is to the third. This is to the second. So my numerator wins. So it's still a whole. And then this is a +4. And that nothing there is going to make the denominator equal 0 by plugging in 4. So it has to be A. All right. We got 10 more to go. I'm going to stop this and make another video. Woo!